Hi, I am here to share with you today the activities I do with nanotechnology in my high school chemistry classroom. My name is Tina Sabatello. I teach chemistry at Maine East High School in Park Ridge, Illinois. I love getting the students excited about nanotechnology. I'm very fortunate to teach in a high school that supports teachers and allows them to use innovation and creativity in their teaching. I have a Google site which I post my activities and resources to, which you can feel free to access, and email me if you have any questions. In the beginning of the school year, I introduced nanotechnology in the unit of metrics. Below you see an image, which is a scan from the SEM. It is a periodic table inscribed on a piece of hair. This is from a short video clip from the University of Nottingham. I pass around the AFM sample to my students and ask them if the surface is smooth, and they all agree that it is. And then I use the scans live at Oakton with the help of John Ireland or Troy Bloom to show them that the surface actually is not smooth. We also scan the surfaces of CDs, DVDs, and Blu-ray to measure the distance across the track spacing and talk about how it relates to storage size. It is a great use of metrics. There you see my students working to measure the distance between the track space from a printed scan from the AFM, which I received from a journal article. Here's a picture of me using the remote access in my classroom, and the scans are happening live as we are observing and measuring our printed scan. You're probably wondering, how would we integrate nanotechnology when us teachers are being asked to do so much more? One great way to integrate nanotechnology, as well as the Common Core literacy standards, is to have students do close reads of texts. Chem Matters offers articles related to nanotechnology, and teachers' guides are available as well to assist you in designing questions or using their resources that accompany the article. One of the activities I did last year, and I'm excited to do again, is the students prepare a hydrophobic surface on a piece of copper metal. I introduced this activity after the students learned about polar and nonpolar molecules. The student in the video that I am going to show you shortly will spray water onto a copper surface, which is a penny, and then what you see there in the image is a copper plate that is coated with chemicals including silver nanoparticles. On the right side we see the SEM image, which the students can then see the copper and silver content from the analysis. So the student will show that the copper penny does not repel the water that is placed upon it. The water accumulates due to the surface tension on the penny. But then the student sprays the water onto the treated copper plate, and you can see the repulsion of the water from the surface because it is hydrophobic. I then bring in videos from YouTube with products such as Never Wet, where the students can see that the products can be sprayed with the Never Wet spray and they also become hydrophobic. They are really excited by the videos. They, matter of fact, recommended them to me because they had seen them before but didn't know what it applied to. Here's some more details about how the copper surface is coated with silver nanoparticles. There again is a scan of the SEM analysis of the hydrophobic surface showing the silver and copper content. An additional resource, this is really great to use, there's many activities on here, is the NanoSEMS resource from the University of Illinois at Champaign-Urbana. Joe Muskin, a professor in the Materials Science and Engineering College, is really helpful. I love this activity he has with physical and chemical properties of silver and gold nanoparticles. When I inquired about some of the materials that were very expensive, he happened to have several items to give me free of charge. He is really a great help. Another awesome website and resource is nanou.eu. If you're interested in role play, where the students debate the positive and negative or pros and cons of using nanotechnology, this is a great site with many of those activities. Earlier this year, the students did an activity with memory metal. I have several samples, one for each lab station, where the students experiment with memory metal. In a moment, I will show you the SEM image scan that I did earlier this year in the summer with Troy, and I share that with the students. Because of time, I was not able to do a live scan with the students. But this year, I am excited about introducing the analysis of conductive inks that I'm hoping my students will successfully prepare. Those also contain silver nanoparticles. I'm going to show you both of these in a moment. Here we go. First of all, the website that I prepared has all my resources here. And then if I go to metals and I click down below, I can see my SEM scan of the memory metal. And again, here you can see the content of the titanium and the nickel, as well as the percent present of each element. In addition, last summer, I also scanned an image of the conductive ink containing silver nanoparticles. And there is the image and the content of silver in the conductive ink. The conductive ink was developed by a student at the University of Illinois at Champaign, and they're marketing it into a product available for educators. Here's a brief clip from their website. So they write circuit scribe, and it conducts electricity. I'm going to have the students both synthesize, analyze, and test their silver conductive ink this year in the unit on electrochemistry. Again, there is a shortened URL for the website. And I want to thank everyone at Oakton Community College for their assistance in helping us to integrate nanotechnology into our classroom. Thank you very much for listening.